All right, let's do this. So you guys remember, today's the 11th. Whee! Do you guys remember, I'm guessing, this? And honestly, I don't think I've written that on the board yet once this year. It's a record for me. Uh, because it's hard not to show it to you because you'll appreciate the simplicity of this. Does anyone know what this is called? It has a name. And by the way, I will be teaching you over the coming week and a half or so three different types of linear equation formats. This one has a name. It's called slope-intercept. The other ones I'll be teaching you are called standard and point slope. And they each have a really important place in our math world. But for today, my mission is threefold. Number one, I want to teach you how simple it is to graph a line when it's in slope-intercept form. That's objective number one. Objective number two is I want to teach you how to graph vertical lines. And objective number three, you can probably guess, is I want to teach you how to graph horizontal lines. Okay, so those are our missions for the day. This should be a very straightforward, simple, relatively short by my standards lecture. So let's get to it. So in order to graph a slope-intercept equation, I'll show you how easy this is. The first thing you have to note is that you would identify that this equation that I put this oval around has y by itself. That's really important. So once you have it in function form like this, where it says y equals, then we're going to, not today, but we're going to spend a day or so manipulating equations to make them look like this. Because when you see how easy today's work is, you'll understand why it's worth the time to take ugly equations and make them look like this. So when you see an equation that's written in slope-intercept form, anyone want to throw out, this is not a guess, by the way, what is the m in this equation? You know who m is. You've known him for weeks. He's our slope, right? And then what is b? B is obviously not going to be b. It's going to be a dang number, right? But what does b represent? Anyone remember this one? Nope. Doesn't stand for, it doesn't have any letters in common. It's the y-intercept of the graph. And what that means is that's the place where your line will slice through the y-axis. That's what we call intercepts in mathematics, a place where something crosses something else. So if you cross the y-axis, that if you're a point like that, then we call you the y-intercept. Obviously, we'll study x-intercepts at a later date, and that's where graphs cross the x-axis. So what we're interested in is this, and here we go. So if I give you an equation like this, under our former understanding, our backup plan, there's nothing stopping us from making a table. And I would pick x's that are divisible by 2, and I'd plug them in and fish hook them and subtract 3 and all that. This is how easy graphing lines can be. I'm going to start at -3. And what again is -3? You guys wrote it down. It's the y-intercept. So what it means is I simply have to go on my graph to down 3. I need to go to -3, but on the y-axis. So when I ask you the question in the coming minutes and days, and I say, where do you start this graph? Don't say at -3, because there's a -3 here, and there's a -3 here. So let's use really good words. You know how I feel about this stuff. So when I say, where do we start the graph? You're going to say, go down 3. So we can very simply and quickly put a point on the graph right there. We now know that the graph will go through that point. And what is this 1/2? It's the slope. And so all I simply have to do is from my y-intercept, trace a slope of 1/2. And we're comfortable enough with slope to understand that slope is just rise and run. How do I track a 1/2 slope, Joe? We're not going to ever use the word over, right? If we don't want detention. Yes. And again, I will never not fight on that hill. Okay. We don't go up and over. We go up and we go right. And the reason we know we want to go up one and right two is because if you left it up to me and I went the other way, let's say I used the red point and I went up one and over two. What's wrong with this line? It's clearly a downhill negative slope, which is just not sensible, right? If you know the slope's positive, why would you submit a paper with a line that goes the wrong way? So let's be real super accountable and tight with the words that we select. We're going to go up one, right two. And you want to repeat that process a handful of times. And the reason for that is because you don't want your points too crowded together. And that's all there is. And then you grab a ruler, make a line, and you're done. Okay, let's go again. How about y equals negative 3/4 of x plus 5? This would be one prior to today that you would not look forward to. You'd look at this problem and think, I don't want to do this. I got to make a table. I got to pick numbers that are divisible by 4, do the fish hook thing. It's a pain in the rumpy, right? Where do I start this graph at? At up 5. So you simply go up 1, 2, 3, 4, 5, place a dot. You should be able to graph these in you should be able to do 2 every minute at least. Tell me about my slope. It's right here. It's negative. So if my line doesn't look like this, then I'm having a meltdown here, right? So let's talk about that. How do I track a slope of negative 3/4? Correct. 1, 2, 3. And anytime I go down 3, I'm going to put a yellow circle here with like a question mark. The question mark is always kids say, should I go right or should I go left? And the answer to the question is just don't be a dingbat. You could answer your own question by just saying, I don't want to be that kid that makes a line that looks stupid. If you go down 3 and you choose to go left 4, you should say, no, I won't let that stand. That line will clearly go the wrong way. So the decision of whether we go right or left is always just based in common sense. So like Embry said, I'm going to go down 1, 2, 3, and I'm going to turn right 1, 2, 3, 4, and then I'm going to do that a couple times and make a line. Okay, let's practice again. You can already see the benefit of y equals mx plus b. It makes graphing lines, provided that the conditions are right. That y is by itself, it makes graphing lines a joke, an absolute joke. How about this one? Where do I start my graph? Don't say -4. And in that one, anything that I'm tight on is because of decades of watching kids start the graph at, and I quote, -4. So that's why I am the way I am, is I play defense against mistakes that I know are inevitable. We can avoid them if we are tight with our words. So I'm asking you again, where do we start our graph? Down 4. 1, 2, 3, 4. There's a slope right there that I can't see. We've had this conversation all year. Is there a number there? What is it? It's 1. And we interpret the number 1, since it's a slope, as 1 over 1, as a fraction, right? So talk me through this slope. Where do I go from my home base point? Don't say over. I'm going to start assigning lunch detentions when you say that. And I know you're coming off of a year where you were allowed to say that. So cut you a slack. I'll give you like a day until I start busting you. Do not say over 1. We go up 1, right 1, because we want to make sure that our line goes the correct way. If the slope is positive, make the line look positive. It is just 1. Correct. You can't see it, but you know that it's there, right? Those darn invisible ones have been like at our door all year. Right? How about this one? Where do we start the graph? Up 6. 1, 2, 3, 4, 5, 6, and then you literally make a point like the graph is going. We're ready. What is the slope? It is not -2 over 2. It is -2, but it's over one. And here I am always telling you simplify, simplify, simplify. But here I kind of want you to unsimplify just so you can have eyes on a top and a bottom number. Having a -2 and a one will give us both sets of directions. I need a north-south directive and a right east-west directive. So I'm going to go down two, and then I got to decide.
Right.
I definitely want to go to the right. And it's not because there's some rule. It's because I want my line not to look stupid. If the line says negative, I'm going to make it go downhill. Right. Good. All right. Let's talk about horizontal and vertical lines. So here's an equation. I'm going to try to keep this short. I promise I'm trying to get you through this. So right now, I will tell you that this line is either horizontal or vertical. And you figured out in math class that there are certain things that you have to be really tight on. Like yesterday's quiz, if you have zeros on the bottom, it's undefined. If zeros on the top, it's zero. There's these little things that you just got to go, I can't forget that. I can't forget that. This is going to be one of them. When you see an equation that only has one variable, it is either horizontal or vertical. Hold on a second there, Jojo. Okay. Do you hear what I just said? If there's just one variable, it will either be vertical or horizontal. So the question for me becomes, which one do you think this is?
Vertical.
Okay, but doesn't the x-axis go this way? But you still think it's vertical? I do too. I'm glad. Thank you for standing your ground there. 29 years I've been trying to get this point across. You will, at some point, want to make the line x equals 4 look like this. And when I ask you why you did that, you'll say, well, because that's what it's x. X's go sideways. Let's take a look at why that is incorrect. I want you guys right now to help me write some points that only make this true, that have 4. Here, I'll start us out. I need a point with his x coordinate as 4, because that's all this equation says. You got to have an x that's 4. So here you go. I'll give you one. 4, 2. What's that? You say 4, 0?
Yeah.
I'll take it. Give me another one. 4, 3. How about 4, -5? Can I do that? I could do this all day. When I graph these points and I ask you, how do I get to these points? What are going to be the first two words out of your mouth? If I say, how do I get to that point? What are your first two words? Right 4. Enough said. Right 4, something. Up to. What are the next point? Right 4, stay put. Next one. Right 4. You keep hearing yourself saying right 4, right 4, right 4. And if you keep going right 4 and making points, up 5, down 9, up 1, down 3.5, I don't care. You can't escape the fact that eventually you look at these points and you see it clearly makes a vertical line. So key to add to your notes right now is that any equation that only has x in it is a vertical line. You guys heeded my warning on the quiz. I was super pleased last night when I graded your quizzes. There were only a couple of people that got the zero thing backwards, the zero no slope thing backwards. But compared to past years, I feel really proud that you guys clearly took to heart what I said. Don't get those backwards. Well, that's how strongly I feel about vertical and horizontal lines. Only X vertical. Put a box around that, put it in your notes. Because again, your brain's going to want you to do it the other way because your brain is an awesome machine and it processes things in a really cool way. And X has always meant sideways to you. Bless you. But an only X line is vertical. So now that the cat's out of the bag, I'm guessing you probably know where this lecture's headed, but let's talk about this equation. Y equals -3. There's only one thing true. To be on this line, you simply have to have a y coordinate that's -3. Give me one. I'll take it. Give me another one. Give me another one. 8. Give me another one. -3. Thank you for not going in the same direction. Thank you. Yes. All of these points, if I say to you, if I ask Jesselie or Hannah or Kobe or Embry or Reese, anybody, if I say, how do you get to that point? The last two words out of your mouth are going to be down 3. Just watch yourself make the points. Right 4, look, down 3, right 2, down 3, right 8, down 3, -3, left 3, down 3. You cannot escape the fact that every single time you're doing one thing the same, and that is you're going down 3. So unavoidably, this is a horizontal line. And I didn't think as a young teacher 30 years ago that I would have to devote any more than 30 seconds to this. But what I now know is that we have to talk about this. We have to talk about this so that we make a correct association. Because again, it's kind of like the zero thing. You're not going to forget this because you're kids or because you're dumb. You're going to forget it because you're human. And now you're empowered to rediscover. So if you show up the day of a quiz and you go, I don't remember y equals, is that this one or this one? You're going to do what we just did as a class and you're going to rediscover it yourself. So to summarize, if there is only an x, it's vertical, and we can put this in our notes too. If I look at an equation and the only variable is y, what can I say for sure? It's horizontal. Take it to the bank. Right? Great. I'm going to pause this for just a second, and then I'm going to quick work through a couple Delta Math questions, and then you guys are going to work, work, work. So I want to show you in Delta Math what you're going to be up against. Oh, look, it's making me sign in. It's cute. So graphing lines. All right. So this is going to be one type of problem that you see. Uh, the quicker you can talk me through this, the quicker I can get out of your way and let you have some peace and quiet without me talking to you. Blue line. Yeah, Jojo. Good. Very good. So it says write the equation of the line. It is clearly horizontal. So in the box, I'm simply going to type y equals, and the height of the line is 1. Y equals, send it. Let's do a new problem. What's this one going to be? X equals. Very good. -2. Because we know vertical is x equals. The location is the key. Okay. Here's one. It's going to have us graph a line ourselves. So first off, what kind of line is x equals -5? It's going to be vertical all day long. So from the drop down, I'm going to choose vertical, and then it's going to make you a vertical line. Hope you're still listening and not staring at your Chromebook, because then you're going to ask and want to know how to do this. So I'm going to grab this yellow dot and I'm going to move it around like this. And since it was x equals, I believe, -5, I'm just going to go place it at -5 and send it like that. So do you have any questions about that portion? Okay, here's the other portion of your assignment is you're going to be given some equations that are in slope-intercept form like this. And it's hard to make this big enough for you to see, but I think that's probably maxed out. There it is. No Chromebooks yet. Where will I start this graph? Down 6. Thank you for saying down 6. And I will make a dot at down 6. Now notice delta is just waiting for me to give it the slope. It knows that we've hooked it. It's like putting a nail into a board on the wall, how you could spin the board around if you just have one nail. We need that second nail to hold the board in place. And that's going to be our slope. What is our slope? Up to right 5, because it's 2/5, right? So I'm simply going to start with my mouse on there. I don't have to click anything yet. I'm just going to move it up 2, and I'm going to go right 5, and all I have to do is click. The line is done. I'm going to submit. The purpose of this assignment is just to get it stuck in your head over and over and over and over and over and over again, the ability to make a line. Make sure your slopes are correct. Where am I going to start this equation? Down 2. What is my slope? -1/1 is the fraction. So talk me through that. Yep. And there's my -1 slope. It doesn't require you to do more than 1 point. What's interesting about this is if you wanted to, you could go like down 8 and right 8. And you see how you're still making a slope of -1. It doesn't care. You don't have to pick the closest point. So do you guys have any questions about this?
Yes.
Yes.
I'm confused why you're going from the first point and not from just, I'm getting the first point.
The -1 at the end of this is where the graph has to cross the y-axis. So that means that it has to cross the y-axis right there at minus down 1.
That point though, usually you just start,
From 0, 0. No, this point is, I sometimes, you heard me say it once, I call it like the home base. So what happens is once you graph your y hook, your first nail, you put it in the wall. Everything you do now spawns from there.
Okay,
So that's the crosser. And again, you can see as I move the line how that point's not moving because it's hooked, right? And I want to nail the board down. So since the slope is 6, that's a fraction of 6/1. So I'm going to go up 6. So I'm going to go up 1, 2, 3, 4, 5, 6, right 1. Done.
okay.
That's it. You guys got this? Rad. All right, your assignment's on Delta Math. Let's get it done before the class is out. You have 16 minutes to do 40 problems. You'll probably be done with 5 minutes to spare, quite frankly. This is a super quick assignment. Super quick.